So this is an introduction to using modules and classes in Python. We'll start with modules. You can save code in other files like file.py and load it into Python like you've been doing with libraries such as NumPy. Let's look at an example of that. So we'll create a simple units file. So we'll go over here to Home, New, Text File, and we'll call it Python, let's see, units.py. Okay. And then we can import NumPy. Well, let's just do a simple units module. So define some variables. Feet to meters equals 3.28084. Meters to feet equals 3.28084. Kilograms to pound mass equals 2.20462, and pound mass to kilograms equals 1.0 divided by kilogram, 2.20462, and then maybe a function like f to c. Let's see, we'll do def f to c, t in Fahrenheit, and we can return t in Fahrenheit minus 32.0 divided by 1.8, and that should convert us to Celsius. And we could put as many other variables and functions in this as we'd like. So if we go up and save it, now we have units.py. Okay, and now in our class we can create, if we want to use that module, we go import units as u, or as whatever you want. Then we can go maybe x in feet is 10, and then x in meters equals x in feet times u dot feet to meters, print x in meters, and we get 3.048 as the conversion. So our library defined a variable called feet to meter, and we can access it using u.feet to meters. We can do the same thing with the temperature. So if T is 212 Fahrenheit, we can go TC equals u.f to c and pass in T, print TC, and we get 100 Celsius, which is 212 Fahrenheit. So we can do that with both functions and with variables. So pretty easy to do. We just make a new file with our Python code in it, and then we import the code. In this case, if the file is units.py, we import units as u, and then we can use any variable or function in the file using u dot whatever the function or variable is. So pretty straightforward, and this is very convenient if you want to organize your code into multiple files, or in this case you could make a very robust units class with all kinds of unit conversions, and then that could reside in its own little module that you could then import when you want to use it without having to redefine all those variables and functions in your local code. So that's a quick introduction to using modules. Classes are a lot more involved, but also very useful, and we've been using them quite a lot. Classes are the way that programming languages implement object-oriented programming. And rather than having really simple variables, where everything is sort of on the same playing field, it's not uncommon to want to group things together based on their functionality. So if I want to, suppose I have an object called a car, it's obvious that the car has properties and functionality that are specific to it. So we might have car dot gas tank size, or car dot gas pedal, or car dot gas mileage, and maybe we have functions that can compute things like the fuel usage based on our current speed. Maybe we have the car dot current speed. So all kinds of different properties and variables that are related to a specific kind of object. And maybe we have another kind of object called a road. And the road has properties like what's it made of, asphalt or concrete, how many lanes does the road have, what's the grade of the road, what's the speed limit of the road, etc. And it makes sense that you would want to group all those properties that are related to the road in their own little object and the properties related to the car in its own little object. So here we'll do a really simple example. Maybe make a circle class. And a circle, the key property of a circle is that it has a radius, and then maybe it has some other properties like what is it like. In this case we say it's round, and then it has some functions that can perform actions on the circle. So the diameter is the r squared. You can calculate the circumference using the circle property r, the area using the circle property r. Let's go ahead and use this. So if we copy the code, go up to home, create a new text file again, and we'll call it circle.py, and just paste that code in. So the syntax, I want to use NumPy inside of this, so I'll import the NumPy library. Then we define a class. Class circle parentheses colon. So this is how to initialize a class. And then inside the class we have a couple of different functions. The first function is called underscore underscore init underscore underscore. And when we create a circle object, this is the function that's going to be created, or this is the function that's going to be called when we create the circle object. So in this case, self comma r equals 0, and then we set an internal to the class variable called capital R, and we initialize it using the parameter that we passed in. In this case, I have a default parameter 1.0 for the radius. And then self.what'sItlike equals round, and then a diameter function d self return self.r times 2, so diameter is r2r, circumference 2 pi r, area pi r squared, and we use NumPy to get pi. Now you'll notice these self arguments here. All functions that are defined inside of a circle that are methods of the circle class start with this parameter called self, and this is a way for the class to get access to itself. So self.r equals r, self.what'sItlike. In other words, if I'm inside the function, I want to have access to myself, so that gets passed in as a default argument. When you call the function, once you've defined it, when you call it, you'll just ignore these, pretend they're not there. You can think of them as like hidden arguments that get passed by default whenever you use a class argument. Sometimes it can be a little bit annoying to constantly type self, and so I'll type at the top s equals self, and then rather than having to type self everywhere, I can just do s dot whatever. So here again, s equals self. It's not a big deal here because the class isn't very big, but sometimes it's more convenient to do that. So here's our class. We save it, and we'll go up to the top, and let's cut this out and see if we can use it. So we can import circle as C. So now we have access to it. And then if we want to create a circle object, maybe C1 equals C.circle, and I can give it a radius, so 2.0, and C2 equals C.circle 4.0. So I have two different circle objects, C1 and C2, and each of those has their own radius. So if I go print C1.r and C2.r, we can see that we get the radiuses that we set, 2 and 4. We can change the radius if we want. C2.r equals 6, and then when we output it, it outputs the value 6 for our radius, so we can use them outside of the class. And then we can compute things like the circle property. So print c1 dot d will output the diameter. c1 dot area will output the area of the circle that corresponds to the radius. We can do the same thing with c2 dot area, and it outputs the area for circle 2. So pretty simple to set up a basic class and to use it. Notice that when I call these functions, I don't need to pass any kind of self argument to it. Area function, self is default, and it doesn't take any other arguments, so I don't have to do anything here. And the area arguments are empty. And so that's the basics of using a class object. And you could have any kinds you want. Maybe you're interested in an ideal gas class where you can have properties like the gas constant. Maybe it holds things like the pressure, molecular weight, volume, temperature, and functions to output different quantities like the pressure given volume, temperature, and maybe you have other functions like non-ideal versions of the ideal gas law that you can build in, etc. So, a quick overview of modules and classes.